All right, here we have lesson 4, velocity on a position time graph. You may also see it as DT graph, as we've talked about. The learning targets that we're going to focus on is to be able to graph velocity on a position time graph and be able to calculate velocity using a position time graph. So we know based off the last lesson that the symbol for velocity is the V with a little line on top representing the direction. And we're focusing on the measurement of the displacement of an object over a given period of time. So when we're looking at a position time graph, there's a slope of a line, and that's going to give us important information about the motion of the object. The slope of a DT graph is equal to the velocity of the object. If the slope of the line is steeper, it's going to have a greater velocity. So here we have the formulas for it, and I apologize that the formula has stretched quite a bit in your notebook from printing. You've seen this formula before. I'm just going to write it off to the side so you may be able to see it a little bit better. The velocity is the change in position 2 minus the change in position 1 over the change in time, which we're going to solve for from time 2 minus time 1. We're looking at a position time graph that describes the position of a frisbee being thrown along a field linearly. So if we look at positive, that is going to be east. And if we're going to represent our compass rose on the side, we know that west is then going to have to be any negative value. So we're looking at this frisbee. 0 is the center. And notice how it starts at 0, but the numbers for your x-axis are just placed a little bit lower. So if we were to draw in where that would be, this is 0. There, makes it a little easier to see. All right, so we're going to calculate the velocity for the section A. So I'm looking at section A. It starts and finishes at those 2 points. And I'm going to use the formula. So I have velocity is equal to position 2 minus position 1 over the change in time, which is time 2 minus time 1. So that would be equal to, it ends at -10. Subtract where it starts, which is 0. Divided by, now let's look at the time. It ends at 4 seconds and it starts at 0 seconds. So we have -10 divided by 4. So that gives us 2.5 meters per second as our answer. And I realize now that I'm going into where calculation B is. Now we also need to include our direction. So if we did -10 divided by 4, we'd get a negative answer, which would be -2.5. The negative tells us the direction. Or we can also look at the direction it's heading in section A. It's heading negative, so our answer will be west. So take a look there. Now we're going to calculate the velocity for section D. So here's section D. This is going to be our point 2. This is our point 1 because the second comes before the other. So here we have our formula, position 2 minus position 1 over time 2 minus time 1. It gives us, it ended at 15 meters minus, where did it start? -25. No, over time, I look, that's at 16 seconds minus 12 seconds to give us 40 over 4, so 40 meters divided by 4 seconds to give us 10 meters per second. And now let's look, what direction are we traveling? We're going upwards, so that would be positive, we are traveling east. So those are our 4 sections. Another way you might see the question is to calculate the average velocity from 4 seconds to 16 seconds. So that would give us from this point to this point. So we're essentially looking for what would be the average velocity from there to there. So let's use our formula. This is where you may see VAVG. So average velocity is equal to total displacement divided by the total time. So that is equal to, what is the total distance that was traveled from -10 to +15? So that would give us 25 meters. And how many seconds did we travel from 4 to 16 is 12 seconds. 25 divided by 12 gives us 2.1 meters per second, and the direction that was traveling was east. So take note, we calculated speed and velocity in lesson 3, and now we're looking at velocity on a position time graph. Sometimes you may also see it as a velocity time graph. I'd like you to give yourself a second to summarize 2 points from today's lesson, focusing on the formulas and the different instances in which you may see calculations for velocity either in a section, or if it gives you over a period of time.